Hello, everyone. Can you guys hear me? So, I finally was able to connect this thing again. But yeah, just confirm. Hi, Salim. Hi, Sudhar. Uttam Kumar. Hello, welcome back. Alberto. Hey, cool. So, yeah, new glasses, right? Still coughing a bit. So, so this this stream was supposed to happen at 3, but I preponed it to 2:30 because I wanted to start early. So, if it drags out a bit late. I did miss my meeting, which was supposed to be at 4, but then the meeting got cancelled. So now we have plenty of time. Hey, MK Chaudhary. Nice. So we'll start where we left off. So let me just switch to my screen share. Parapa, parapa. Okay. Where am I? I should be smaller and here. Okay. Much better. So yeah, as I was saying, if I go to playlists now, you see 116 videos. So if you go to learn Python, this is where so it shows 11 months because today is like exactly the date when it was streamed. Tomorrow it will show. Yeah, now it shows 1 year. It has like nearly 5,000 views, right? I went ahead and added these chapters as well. So I was watching what all was covered so I can take it forward from there. So in my opinion, they're like, you will see. See, 1 year ago. So yeah, we started with the introduction of Python. We worked in the Python REPL. Then we learned about the 5 pillars of programming: variables, then conditionals, which was if else, loops and iteration for I in range sort of things. Then we covered functions. So we covered functions, but not like, there are still a few concepts that are essential for you to know. So we'll cover that. And then we'll jump to the 5th pillar, which is classes and objects. And then we'll see some nice application stuff. So yeah, I have use cases and we have to implement them. So let's get started. Drop an emoji, by the way, if you are ready. See, congrats on 100 subscribers. So I think at that time I had like crossed 100 subscribers. This was episode 3, if I'm not wrong. Cool. So let's start. We are in this one. 5 people are watching. Let me just refresh to see how many are watching now. Hopefully that doesn't go down. Nice. Let me just go to nope, nope. Yeah. Just one time checking again. 8 watching. I think I will do a third iteration advanced where we will see debugging some more things like context managers, etc. etc. So that will come after this. Cool. So let's get started. We don't need the browser today because we are not going to work in web part of it, only the pure Python side of it. Cool. Let's start. So let me create a new directory, mkdir python playground cd python playground. I will open this up in VS Code. Cool. I don't want to update now. And I have an empty directory here. And so where should we start? Let's create a file. You can call it anything. I'll call it main.py. And here we will start our stuff, right? So we learned how to create a function, right? What are function? They are reusable pieces of code which you can write. So for example, we wrote add a comma b, return a plus b, the simplest of the function, right? So what was this doing? Like, so this stores this code for future purposes, and anytime you want to again want access to this logic, right, the addition logic, you can just call it like this and provide the arguments. So whatever you pass here are called arguments, right? So if I pass 1 comma 2 and print it, right, and then I can run this file using python 3 main.py, and it prints, if I zoom in the terminal, 3. So let me just move myself to the other side. So you can see it indeed prints 3 because 2 plus 1 is 3. So this is what we covered about functions. They can return value. They can even, like, whatever you want, you can do in this function body. And whenever you call it, it will be there for you. You can call it again and again. That's the benefit of functions, right? They help you write dry code as well. So if you notice, right, there are some functions that we saw, like this print function. This lets you do this sort of stuff. So for example, I give it 4 arguments and print, it will print all 4 of them with a space. You can even like say, I want them to be separated by a dollar sign, right? And then if I call, they all 4 will be separated by a dollar sign. But how does this print function take variable number of arguments? Because if I go back, let's just undo and go to our add function. If you try to pass in a third thing here, right, and try to call it, it will say it takes 2 positional arguments, but 3 were given, right? Exactly. A and B are the 2 parameters we have defined here, and we are trying to pass 3. But how does print function do this magic of, like, let the user pass how many number of arguments he wants and I will print it? So this is where star args comes in, right? So you can say, let's just for now say star args, and I will just print it, whatever is inside that, and I will explain what it does, and I will call this, right, with variable number of arguments. Now I don't have to worry. I will explain why. Let's just call, and as you can see, it is a tuple, right, which contains 1, 2, 3, 4. So when you write this, right, star, and then you can call it whatever you want, right? My args doesn't matter. So let's do my args. You will see the same output. You can call it whatever you want, but the more important thing is the star. So what Python will do, whatever arguments, positional arguments, keep in mind, positional arguments the user passes, it will store them in a tuple and give you inside this variable. So now if you want to implement an add function that can print a sum of any number of arguments, right? This or this, right? You can just call the sum function here. Python has the sum function out of the box, and see 6 and 10. Nice. So this is the power of star arcs. Usually it is called star arcs, so I will leave it at that. So what if you want at least one thing, right? So you can say a comma this, and now notice the answer is incorrect because we have to add this as well. So what will happen is, I'll tell you, let's just print the args again. I'm just printing args, and let me also just print a, right? And then I will say print 10 comma 11 comma 12 comma 13. Let's say 13, and I will run this program. Okay, why doesn't it print this? Weird. Let me just comment this. Oh, see, I didn't call add, I'm calling print. Haha. happens. So now see, now 10 is A and the rest of the stuff is passed to args, right? So this is the magic. So you can give any number of positional parameters first and then star args, right? So remember this, you can't do this thing. So if you try to do this, right, you will see add misses one required keyword argument A. Because what Python will do, it will put all of this inside args and what is left for A? Nothing. So it should always come at the last, the star args thing, right? Nice. So now we have a add method that takes at least one thing, and let's fix the logic here. So what we want to return is A plus sum of args. Now this will give you the correct answer. 1, 2, 3, 4. We aren't printing this, so let's print it. 10. Nice. Any doubts in this? So this was star arcs. Cool. So let's write one more function. Operate, right? Which takes two things and an operator, right? Then if the operator is add, it will return A plus B. I'll explain what I'm doing. Elif operator equal subtract. There is easier way to do this, but I'm keeping it simple. Cool. So now you can say print operate 4 comma 5 add. So what will happen is, what this function does is it takes three arguments in total, A, B and an operator. So it will say, like, what it is doing is it is checking what is the operator. If it is add, it is returning the addition of those two numbers. If it is sub, it is returning the subtraction of those two numbers. So it should print 9, which is very correct. Yeah, almost. Still some residue remaining. So yeah, hopefully it gets better in a day or two. So what if I want the default operator to be add, right? So I can come here and say add. And now if I don't pass anything here, right, this will add by default. So this is how you add default parameters or default arguments in your functions. Nice. So I will change this line of code. Just notice what I'm doing. And I run it again. Same output, right? Nothing changed. So you can pass in this with the names as well. So you can say I am passing A is 4, B is 5, right? This is called keyword arguments, right? So you are giving a keyword as well. This is the keyword, right? A and B. So it matches them with A and B here. So you will ask what will it help us to do, right? So it will help us do things like this. So if I don't pass anything, right, it's 0 because default value of A is 0, default value of B is 0. Now what I can do is I can say I'm passing 0. If I say 0, right, it will be A because that's the first one. But I don't want to follow the order. I want to pass B, right? So I can say I'm just passing B. You can assume A is 0, operator is add, and let me just run. C 0, and I can say 10. So the output will be 10. So now you know why are keyword arguments useful, right? And there is just one rule you have to remember, that all keyword arguments, right, must come before positional argument. See, non-default argument follows default argument, right? So you can't say that I will not pass C. You have to pass C. And if I do this, right, 10, what will Python know? What does Python know that what are we passing this 10 for, right? Is it A or B or C? That's why what we have to do is we have to tell it that C will be the positional ones. So all the positional arguments which don't have this default value, right, must come first. So Python can guess, okay, if they have passed 10, that means C will be 10, right? And then the rest of the stuff. Make sense? Cool. So this was keyword arguments. You might have seen this in framework being used. So when you do frappe.getAll, sometimes you can just pass, say to do, right? GetAll is also a function, right? Behind the scene, it is a function. So sometimes you can just pass filters directly. Or if you want to pass the fields and filters, you have to write this, right? Fields, filters. So these two are keyword arguments. This is a positional argument, right? Now you understand why this is that. And sometimes you don't give field. What is the default fields it returns? It returns the name. So you can think of how it might be defined in the backend. So there might be a getAll function, right? Which asks for the doc type, fields, filters. See? So if the user has to provide the doc type, right? This one, fields is default empty. So you if even if the user doesn't provide it, it works. Even filters has a default value. Cool. So this was arguments, default arguments, and keyword arguments. So I'll tell you why I'm building up to here. So I'll write a function called my function, right? Which takes some value AB, right? And our args. So whatever else is left, it will get stored in args. And let's print A, print B, print args. Now you have to guess the output. Guess the output. Print 10, 20, 11, k equal to 11, 10, right? Guess the output. So Jinesh says, hi Hussain, this is great. Can I suggest you to, as mentioned about, to also create a series demonstrating creating using APIs in Frappe? Sure, we can do that. So for this special episode, I'm wearing this t-shirt. See, PyCon India. If you are able to guess it correctly, let's run this. So, sorry, I don't have to run print. I have to run my function. Okay, same mistake twice. Now I have to keep this in mind. Let's run it. And you see, got an unexpected keyword argument, K. So what you might have thought is that args will catch this as well. So args only catches positional arguments which are this, right? Which will be 20 and 11 in this case. Like A will be 10, B will be 20. Args will catch the 11, right? But k equal to 10 it won't catch because it's a keyword argument. It's not a normal argument. So in order to catch that, Python provides a way, star star quarks. Again, this name can be anything. The double star is the thing. So now if I print quarks and let's print it. See, A is 10, correct? Normal thing. B is 20. 11, there is no keyword argument, but we are doing a catch-all kind of thing that it catches all the other keyword, like all the other normal arguments and stores them in this tuple, which is just 11. And this quarks, right? It will catch this 10 and store it in a dictionary with the name as well as the value. This wraps up args and quarks. So many places you might see this. Don't get confused. So this is just to catch any additional arguments like this 11. Maybe I will write 12 as well and run again. So you will see it is catching 11 and 12, this args, and putting inside a tuple. And star star quarks catches any keyword arguments that are not mentioned here. So if I mention k here, right, and print that, quarks is empty. See, because k equal to 11 caught this 10. So this only catches anything that is not caught by here, and this only catches anything that is not caught here. Yeah, this example you can keep in mind and it will be easier to understand. Nice. Any doubts in this? Star arcs and star star quarks. Nice. So let's proceed. Nice. So this is advanced functions if you want to call it. Not yet. There are decorators as well, which we'll cover towards the end of today's stream. So let's see what's next. So there is something called a scope in functions. This is the last topic for functions. We'll proceed to classes after this. So I'm going to write some code s equal to 0. Okay. And add an s equal to s whatever number. Let's say a, b, c. I want to store this a plus b plus c, call add 1 2 3, print s. Okay. Now guess the output of this. So I've declared a variable like which is outside the function s. You can call it a global variable, right? It's globally available, not inside the function. And I'm setting it, the s value, to a plus b plus c, whatever the user passes a, b, c. So what will be the output of this? 6, right? 6 or not? Any guesses? Should I run it? Let's run it. 0. Why? Because as soon as you define a new variable inside a function, it is inside the function scope. It does not say that, okay, I'm going to refer to this thing, right? So it still remains 0. This s is a very new s. This s is not this s. So what if you want to use this s? So you have to explicitly tell Python that in this function, I am going to refer to the global s. And now see, 6 is the output. So this is the concept of global scope and local scope. So if you don't provide this, it will create a new scope. So this s is a new variable inside the add function and it is only reference inside this function. But as soon as you tell Python that I want to refer the global s, so then it start referring to this s. And when you set this, it will update this thing. Make sense? Yeah, also referred to as namespacing. So you are saying that I am referring to the global one. And if you don't say anything, it will create a new s just as part of this add function. Make sense? That's it for global and local. So not very tough, just play around with it and that's it. So usually you don't do this. Global variables, playing around with global variables is not that recommended. So Turker says Python doesn't seem to allow pass by reference parameters. It only allows passing by value. So it does depends on the data type. So if I have a list, right, let's answer that question. Pass by reference and pass by value. That's a typical function question. So suppose I have my list here, right? It's an empty list. Def add 10. That's my function. That takes a list and appends a 10, right? And then I call this add 10 with my list and print my list, right? So what do you think? Will it still remain empty or will it have the 10? It has the 10, right? Because when you pass a list, it passes a reference to the list, the original list. This is not going to create a new list. But if you have the atomic data types, let's say def add, let's say magic, right? And you try to do this. And when you call it magic, say b equal to 10, b. What do you think? This b will change to 10, like b will change to 20? Nope. So these are atomic data types, right? Integers, strings, they are passed as is, not the reference. But in the case of stuff like lists, dictionaries, tuples, etc., they are passed by reference, which means that this list itself, this my list will be passed, and when the function calls append on it, it's actually changing the list and not a copy of the list. So it's not a copy of the list, it's an actual list. But in this case, when you pass b here, right, you're not passing the b variable, you're passing the value 10. So when you set it to 20, it doesn't matter. It will still be 10. Makes sense? Now is it clear, Tarkar? Cool. So we covered, like, not my plan, but nice that you mentioned this. So that is out of the way as well. Cool. Let's jump to classes now. The fifth pillar, classes and objects. So till now, we have played around with variables and functions, right? You can say, like, let's implement. So there is a requirement. We want to implement a simple power bank digitally using Python, right? It won't be attached to a physical power bank, but it will measure the what is the battery, like it will help us charge the power bank. So let's see how we can do that without classes and objects and then with class and object, right? So I will say my power bank battery is 10. Okay. And so we have to provide two methods for the user, functions for the user, one to charge and one to use, right? So let's say it starts at 100%, right? Power bank battery, power bank charge, should we call it power bank charge, right? And I'll write a function use battery, right? That should decrease 10%. And we have to use the global keyword because we want to refer to this power bank charge and not something else, right? And then we want to charge battery or charge power bank, let's call it charge PB, which will again refer to the global power bank charge. And when you charge, it will increment it by 25%, right? And I will change this to power bank as well, PP. So now we have a power bank. So let's print the initial charge. Let's use the power bank twice. So now let's print the charge again. Let's charge the power bank thrice. No, let's charge it once and then print the power bank charge again. Right. So what I'm doing, I'm printing the initial charge, which should print 100. Then I'm using the power bank twice, which means it will go down by 10 and down by 10. So net 20. So this should print 80 and then I'm again charging. So it should add 25% to it. Let's do 20. So let's run this program and exactly it prints 100, starts at 100, then you use the power bank twice, so that becomes 80, and then you charge it again, so it becomes 100 again. Makes sense? So we were able to achieve it. Now this is one power bank, right? I want to have 5 power banks. How many? 5 power banks. So typically what you would do, you don't know classes, right? What you will do, you will create a list of power banks or a dictionary. power bank 1 has 100 power bank charges, right? Power underscore bank underscore charges, and you can create pb2 is 100, right? And then I don't need this. So now the user has to tell which power bank, the name of the power bank, right? And this will refer to this. I'm just changing my program so it supports multiple power banks. And now we have to tell which power bank we are using. First, let's use one, then use two. Then I will charge one. This all is build up. Yeah, we don't need the global keyword if we are just, let's see. I think it should be. So instead of this, we have to give it the name as well, right? So now we are saying use power bank and we are asking the name from the user and then we are decreasing it by 10. Similarly, let's try it out. So Turker suggests we can do it without that as well. So I will charge it at 10. So what am I doing? I am first using 1, using 2 and charging 1. And I haven't charged 2 yet. So let me just run this. And as you can see, indeed we didn't, because there is no name clash, right? That's why we don't need the global keyword. If there was a name clash, right, like this, indeed, what we'll have to do is we'll have to use the global keyword if we want to. By default, it will refer to the local and then it will look for it in the global scope. So if Python doesn't find this in local scope, it will go in the global scope. Makes sense? Something new. So yeah, now we are tracking two power banks, right? Power bank 1 was 100, power bank 2 was 100 when we printed this line. Then we used both of them, so both became 90. Then I charged one of them, so one became 100, one is still at 90. Make sense? So what user has to do to create a new power bank and track it? So he's writing some other code. You have written this code, right? You are the creator of this code that implements the power bank charging logic and using logic. So what he has to do is he has to get access to this dictionary, add a new power bank 3 with 100%. This all he has to do, right? You can't do this. Or you create a new function that adds a new power bank to this. And again, then this becomes messy, right? Currently it has charge. It might have other properties like what is the color of the power bank, this, that. This is where object oriented programming comes in. Classes come in. And I'm going to implement this same thing using classes and objects, right? And you will see how easy it is for the user of this interface, whatever we will create, right? To create different power banks and call methods on them separately without even maintaining this. Okay, I want to give me the name of the power bank which you want to decrease, right? Every time the user has to remember the name and pass it properly. And then we have to internally do stuff and so on and so forth. And suppose someone writes the code that goes and changes this completely somewhere. Suppose your user is playing around and this happened. So this is one of the major issues with global variables, right? You might not know what side effects are happening. So usually global variables, not a good idea. There are cases, but not this one. Cool. So let's comment this all out. And now I'm going to write a class, right? So think of a class like a blueprint, right? So you are not writing one power bank. You are telling this is how a power bank will look and work, right? Look in the sense what properties it will have and what all actions you can carry on it, right? Charge or use, right? So this is the blueprint. This will create how it will act, not an actual object of power bank. We'll see how to create actual objects. Let's define class power bank. In Python, it's convention to use Pascal case for classes, right? Snake case for functions. So now I'm going to write something. Just bear with me. I will be right back. Cool, I'm back. Are you guys still here? Sorry. So, an interior designer dropped by. I'm getting a new studio. So, where were we? Yeah, display charge. That will just print current charge, right? And oh, there has been some stuff going in the chat. Time for a Turkish coffee. Suleiman tea from Turkey. Never heard of it. Nice. Okay. So I want to visit Turkey as well someday. Egypt as well. Egypt recently I've been thinking. So it should display. So we can use f strings. So f strings are let you use variables in the strings. So you can just say self dot. Just don't worry about the self part. I will explain. Okay. So just observe this part. This looks like functions, right? There is one function, then two function, three and four functions, right? All take the first arguments as self. You can call it anything, but they take one positional argument. Am I audible? Is anybody here? Just confirm. So this is how you create. Yeah, maybe. So we created a new class, right? Which is called named power bank, and then there are four functions inside it, and when they are part of a class, they are called methods, right? So there are four methods in this class. That's the terminology. This is a special method. I'll come to it. Whenever you say double underscore something, double underscore, there is special meaning in Python. And then I have a use function, charge function, and display charge, right? So we had use and charge here as well, but it was referring to a global thing and then increasing. But here I have done self. So so you are here defining that a power bank will have, so ignore this part, this one will have a charge property which will start at 100, okay? And it will have three methods, use, charge, and display charge, which will in- increase the charge, decrease the charge by 10%, increase the charge by 10%, and one will print it, right? So this is, we have defined, okay, there will be a power bank like this, and that is fine. So how do I create an instance of it? It is called an instance on an object, right? So let's just go to the whiteboard. That will be easier to explain there. Simple concept, nothing complicated. So I will tell what we are trying to do. X Kali draw. Hopefully this thing works. Come on. Okay. Let's go down here. Okay. Yeah. So now I'm here. I'll just select blue color. That is fine. Come on, let me write. Yeah, now it works. Cool. So we define that a power bank will look like this, right? We defined a power bank class, right? And let's decrease the stroke width. And it has a property, right? Called charge. And then there are three methods or the actions you can carry on a power bank, right? Which are use, right? Charge and display charge. Okay, three methods. But you have not created a power bank yet. You have said that, okay, this is how a power bank looks like. a blueprint of it. And now you create instances of it. You can say this is one power bank, right? This is two power bank. This three power bank. I'll tell you how to create these instances. So this is more close to the real world, right? In a real world, power bank is an object and there can be 10 power banks, but all the 10 have same properties, like it has a charge, you can use it, you can charge it again. So now, since this object is a power bank, this will have a charge of its own, right? This will have use, this will have charge, and this will have display. And when you call use on this particular power bank, it will decrease its charge, not the other two, right? Because this one is a separate object, this one is a separate object, this one is a separate object. Although they are all power banks. Makes sense? Very close to real world. So let's do one thing. Let's create our first power bank. As easy as, let's give it any name you can call it, and then just this. So what this will do? This will create an object of power bank. So if I take an eraser and erase this part, what we right now did was created a power bank PB1. And since it's a power bank, right, this line means that. So it has the charge, use, charge, etc. etc. So you can directly say PB1 dot display charge, run this code, and it displays current charge 100%. So now you will say, what is this init and what is this self, right? Self 1, 2, 3, 4, 5, 6, 7, 8 times it appears. So self refers to this guy here, this particular, this is self. So when you say PB1 dot use, right? You are not passing self. I'll just move myself on this side. So when I say PB1 dot use, I didn't pass, like even in display charge, right? I didn't pass self. Did I? No, right? Python automatically passes this object itself, this power bank itself, as the self, right? So when here, okay, come, just use the pen. Def use self, right? So this self, Python automatically passes this PB1 as the self. Which object you are calling use on? Because there can be 10 power banks, right? So I am calling use on this power bank. Use method on this PB1 and self refers to PB1. So now easily you can read the code. You can see it displays the charge and it prints self dot charge. Self refers to this particular power bank, which is PB1, and charge is the property we defined in the constructor. So now what is a constructor? So this will be called whenever you create a new object of this class. So you can say print creating new power bank. Now I run this code. You will see it shows creating new power bank, which is coming from here. And if you create, let's say, 3 power banks, right? You can change the name PB2, PB3. See, creating new power bank, creating new power bank. So what Python will do whenever you create and use this, right? Behind the scene, it will call this init dunder method. They are called dunder because double underscore, right? And we are setting self dot charge. Self refers to the power bank, its charge property to 100. And similarly, when you call use, we are decreasing its charge property by 10, which was initially 100. Init, right? Initial. At the time of creation of the power bank, it was 100. So you can clearly see the resemblance between it in the original world, like in the real world, and the digital world. So this is why this is a very popular paradigm. So let's do some stuff and you will clearly get better understanding. I created two power banks, let's say, right? PB1 and PB2. And I will say PB1 dot display charge, right? PB1 dot use, right? PB1 dot charge. Let's use it 4 times. Then again PB1 dot display charge. Predict the output. So what we did, we created two power banks, right? Objects, they are called objects. So one PB1 is one power bank, PB2 is two power bank. And then we are calling display charge for PB1. So it should be int object is not callable. Oh, charge, no. So see what we did here. One of the biggest mistakes we did was we called this charge and the function as well charge, right? So let's call this remaining charge instead. I will rename this so this doesn't confuse the method with the property that we set, right? Now you run this and you will see this line 39 created a new object which went here and print this, right? And what happened was it created PB1 and set remaining charge to 100. This is what this line does, right? And done. And then the other line PB2, maybe I'm going very slow, but I like this is the core of all object oriented programming. Remaining charge 100 PB2. That's why two print statements, right? Creating new power bank, creating new power bank. So both power bank got created. And now we are calling PB1 dot display charge. So what is display charge? This method. So in this case, self will be PB1 because we are calling that on PB1. So Python has to know, right? What is the, which is the one particular instance. Are you calling it on PB1 or PB2? This is what the self refers to. So now when it sees that I am calling that on PB1, it will show the remaining charge of PB1, right? Which is 100. And then I use it 1, 2, 3, 4 times, which means 40%. Then I charge it once, which means it again comes from 60 to 70. And then again I call display charge on PB1, which is 70. So this went when I called PB1.use, right? It decreased the remaining charge to 90. Then I called again use 80, then 70. Then I called charge like 60. Then it became 70 when I charged it again, right? This is still intact. So each of them has a remaining charge, right? You create a third one, fine. It has its own state. We call it in front end sometimes. So remaining charge is its state and I am acting on its state. Is it clear? Classes and objects. This is the base of it. So this is, I like to use the word blueprint of how a power bank will look like and act, like what state will have, it will have, what all the properties will it have, and what all methods or actions you can carry on that, right? This is neat, right? Now the user of, you just define this thing once and the user anywhere he can import and use it like, okay, I want a third power bank, just give me this. Done. Is it clear? Any doubts in this? This was the basics of classes and objects. There is a lot of stuff that you can learn, but this should give you an idea of where to look for. You can call it anything. This self is like just a convention. Standard, like everywhere you see it will be called self. So init is one of the special methods. There are other special methods. So suppose I do nothing, right? I directly try to print this object. I created PV1 and try to print it, right? I'll just give you a basic of. So it says main power bank object at this memory. Cryptic thing, right? So it says it's an object of the power bank class right? Main is the name of the module. At this, so this is the address, the ID where this object is stored, right? In the memory, RAM. So we can control this using magic methods. These are called magic methods or dunder methods. So I can share the documentation. So once I am making the course out of this streams, I will share it in the course description. Otherwise, it will be in the description of the YouTube stuff. So yeah, you can control this using def underscore underscore REPR, right? So, and I will say, so I'll share the docs REPR Python, right? Let's not go to Geeks Broad Geeks. Dunder methods in Python, dunder or magic methods, right? Let's look for the official documentation. Yeah, see, there are lots of them. To be called by built-in to return a machine-readable representation of a type. Instance of class. So there are two. There is stir and there is REPR. Let me just return this. F power bank. Just bear with me. I will explain what it does. Self dot remaining charge. See, the representation changed, right? REPR is the representation. So when I try to print it now, it uses our representation function to get the string which will be displayed when you try to print it, right? Here. So this like magic methods let you customize the behavior of the class at the class level itself. Nice. So this was it for classes and objects. Any doubts? Otherwise, we'll proceed to the next topic, which is file handling. So there is inheritance also that you can have. So I'll just give you a brief, just research about it later. You can create a class, super power bank, or let's say class colorful power bank, which inherits, which is colorful power bank is also a power bank. So it will also have a remaining charge. It will also have use charge. So what inheritance will do, it will have all of the properties of a power bank, but you can define additional stuff here, right? You can say, I want show colors, right? And you can say print red, green, blue. And now when I create a colorful power bank, right? Try to print it, it still uses the wrapper and it's still calling the creating a new power bank, right? Even though we are creating a colorful power bank, it also has the display charge method, right? See, but additionally, it has show colors. See, red, green, blue. This is inheritance in a nutshell. Colorful power bank is also a power bank. So it inherits all of this, plus it can extend, right? Done. Any doubts in this? So now you are able to understand when there is something called Okay. Now do you get it? What is this? When you create a new doc type in Frappe, right? You create a controller, like you get a file. If you create a vehicle doc type, you get a vehicle.py file which has a class which inherits from document. So document is the one that is doing all the magic before save, on, update, all of the properties that a doc type has, it brings to your vehicle class as well. And when you do get doc, right? When you do get doc vehicle, vehicle ID. So maybe I created a power bank doc type, right? And it has a name of like let's say V1, right? When you do frappe.get doc. So behind the scenes, what it does, it creates a new vehicle, right? And loads the data from the database using select star from vehicle where name equal to something like this, not exactly this, but something like this, and loads it inside a vehicle object and returns. So if you try to print a doc, right, it shows that it is of type vehicle and its name has this, right? This is the concept. Like, but you will see when how does Frappe know when to call before save this that it knows. So when you call doc.save, right? You haven't defined save here, right? We haven't defined. We do have before save, but we don't have save. So think about where it is coming from. We don't have it in vehicle. Similarly, we didn't have a display charge in our colorful power bank class. There is no display charge here, right? In the colorful power bank. So where is it coming from? Similarly, vehicle doesn't have save. So where is it coming from? Tell me. Rehan, are you there? This save is coming from document. Similarly, this display charge was coming from power bank, right? It is inheriting. So this save, insert, that, this, everything is inside the document class. Yeah. So when you look at the Frappe code and you see how save is defined here, you will see it calls before save for you. Your before save. That's it. Like this, there is no magic going on in framework, right? Simple Python concepts combined together, and you will understand like all of the code that is written there. Some magic, but it all boils down to Python constructs like this. Is it clear? So this is what inheritance is. Even though vehicle doesn't have a save or an insert method, right? It does have document as the parent, right? In inheritance, it is called parent child. So this is the child class. This is the parent class. Done. Classes and objects are clear. Let's clean it up. Cool. Let's go to file handling. Any doubts, please ask. Be happy to cover. Cool. Now is it clear, Rehan? The concept behind controllers. In Frappe, we have used object-oriented programming in classes and objects very heavily. Cool, let's start. So what is file handling? File handling, right? Handling of files. Suppose I have a file in my file system. Let's say, okay, ideas.txt. Text file, normal text file, nothing fancy. And I will put in some content here, right? My idea number one is a flying Scooter. Idea number two. What are the ideas that I have? New studio with neon style. Something like this. You can have a lot of more of this. These are my ideas. Hey Ravichandran. Cool. So yeah, I have this ideas.txt file and now I want to, so you are as a user of the computer can anytime look at it, modify it, do stuff, right? The main thing I want to cover here is how you can do this programmatically using Python. Open files, write them, read them, modify them, right? So suppose what I did accidentally was ye, ye, right? I have added ye and I want to remove this from this file programmatically. However many times it appears, I don't want to do it manually. So you can think of this as like censoring comments, right? There might be some comments that contain some word that you want to redact, right? Similar use case. So first of all, we have to read this file. We have to read the contents. We have to fix the contents and write it back. Let's start. So I'll go here. There is an open function in Python that lets you open files. You just have to give it the path, relative or absolute. So since we are writing code in main.py, if you directly say I want ideas.txt, right? It will know where to look for it. It will look in the same directory as the code, right? If it was inside some text folder, then it won't find it. So then we have to say ideas slash, right? Oh, text slash. Cool. So this will open the file and return a file object. See, text IO wrapper is the class. You don't have to worry about it. But now this objects gives you methods that you can use to read the contents of the file. So you can say f dot read. I will store it in a variable, whatever content I have read, and let's just print it. Right? What did I do? I opened up this file. So I told Python that open this file. I gave it the path or the location where the file is in my computer. So in this case, it is a relative path. It means in this code file, look for a folder like in the same directory as the code file, which is Python playground. Look for a folder named text. Inside that, there is a file called ideas.txt. Cool. I will run it and see. Here we have our content. Nice. Right? We were able to read the file, contents, and print them. Nice. So now don't forget to close the file because when you open a file, Python creates a link to the file. It takes some resources, right, to manage that link in the RAM because files are in the ROM, they are in the disk, right? So Python has to do some magic to connect them in the RAM layer, right? So you can read and do stuff. So it uses some resources. As soon as you close, that connection will be closed and the resources will be freed up. I will tell you a way on like you don't have to manually close it, but this is, let's run again. Nice. Any doubts in this? How you can read simple text files? So we still have the task at hand. We were able to read it, but now this is a string, by the way. Content, it gives you it as a string. So if you try to say, I want the first 100 characters, you will get the first 100 characters. Let's do first 10. See, I got the first 10 characters, right? This is string. So you can hover over and it will show you the type as well. But what was the actual use case, right? We wanted to replace ye, right? With ne. Let's say we want to replace with ne. So now I can say content dot replace since it's a string and it takes the old one, which is ye, and I want to replace with empty string or ne, anything. Let's remove it. So empty string means it will remove it, replace it with nothing, right? So it returns a new string instead of replacing in the same. So it won't change the content. It will give you a new string with ye replaced with empty string. So now let's print the fixed content. I can give it a different variable name. Let's say fixed content. So we have fixed or censored content. Let's print the censored content. See, ye is gone. Both the ye's are gone. Half of our task is done. 60% is done actually. 30% was opening this file, reading its contents. 30% was doing the actual logic, right? So this is a very good example of the input process output cycle. We are yet to implement the output part. What we want to do, we want to replace the file contents. So let's open the file again. Like I closed it after reading it, right? You can open the same file again. So now we have fixed the contents. Let's open up the file again. ideas.txt. This time I'll pass a second parameter or second argument to the open function, which will be w. So there are different modes in which you can open files, right? The default mode is R. So here if I don't pass anything, it will be R, which means read, normal read. And then if you open it up in read mode and try to write, right, it will give you an error. See, wait, let's try to write something, run it. See, not writable. See, because we said I want to read this file, right? So it won't let you write. So default is R. If you don't provide, it will be read only. But I said W here, which means write. And bear in mind, this will, if you write something to this file and you open it on W mode, right, it will override anything that is there. There is one more important mode called A. It will append anything, right? Whatever new thing you write, right, it will append in the existing content. So right now I want to replace it. So W is fine. And then I will say f dot write censored content. You can give it the content you want to write. And let's close this again. And let's run this. Let's see our ideas file, whether it was fixed. Nice, it is fixed, right? What did we do? We opened a file, we read its content and closed it, right? Then we fixed the content. This can be any logic, right? You call an OpenAI method to fix it and fix the grammar of it or anything, like if you want to play around today, right? Just experiment with it. Make a request to the OpenAI to fix, like add some uh, indecent words here and try to use the OpenAI to censor them and use file handling for it. So now you can combine stuff, right? You can read whole directories, right? And loop over each file, fix all of them together. Once you have access to the code part of it, right? It is very interesting of stuff what you can do with this. So then I fix the content, then I again opened this, but this time in write mode because I want to write to this file. I wrote the content, there is a write method on file and closed it. Done. First task is accomplished. So now as an exercise, I am giving you an exercise. write a program to read a file called story.txt and replace all uppercase letters with lowercase letters and vice versa. Cool. This will give you practice on file handling. Nice. Now, the second task we have at hand is we have a CSV file, right? Let's create a CSV file right here, data.csv. Let's say John 11, Jenny 12, Jacob 17, whatever. So this is a CSV file. We call this CSV, comma separated values file. So this is like looks like an Excel sheet because it has rows and it has two columns and the format is special. This is not a normal text file. This is a text file, but it is formatted in a certain manner, right? So Python has inbuilt standard modules to read such sort of standard formats, right? CSV is a very standard format. So is JSON and YAML. So this sort of standard file formats, although they are text, they are normal text, but they are formatted in a certain way so it can read it nicely and parse them. So this process of processing, this uh, method of processing is called parsing the content, right? So let's do that. So what I will do is I'll open this file, right? The first step is to open the file, data.csv. Let's open it up in read mode, which is the default mode. That is fine. So you can just omit this altogether. So I will say f.close. So I will tell you a method when you don't have to remember to close it. So I won't manually read it. So I can read it manually. Just show you, just to show you that I can read it manually. I'm not telling I can't. Right? I can call read and I get the content, but this is not how I want it, right? I want it nicely in a good data structure that I can process, right? I want to show the sum of this column. That's what the task at hand is, right? So if I do it manually, I have to split it, comma, store it separately, convert this, that, do a lot of stuff. And comma is not just one of the, it is just one of the delimiters. These are called delimiters, right? Which separate two entries, two values. So default delimiter is comma, right? But you can have it something else as well. And then the processing, you have to change your program to process it, right? So why not use the out of the box CSV module? I'll just import it, right? Import CSV. As easy as that. You don't have to install it. Comes out of the box with Python. Part of the standard library. And then instead of reading this myself, I will ask the CSV module to read it for me and it will process it as well. So CSV dot reader, and you have to give it a file. What do you want me to read? Which file, right? And then it will return a reader, right? I'm giving you a lot of small examples of file handling so you get the idea, but you can dig deeper on what you want to do. Then I can say for row in reader print row. I'll explain what I'm doing. Let me run it and see it processed it, converted each row in a list and each column as a separate value. Nice, right? We didn't have to do any processing. We still have to convert this data type because the CSV module can't guess if you this is a string or a integer, right? Because we don't have commas or anything here, like quotations. Right? So this is CSV reader. Quick and easy way to read CSV. There is a better way. So suppose if you have column names, name, marks, there is a dict reader, right? And you can pass in the field names, which will be name and marks, right? And okay, it is weird. Okay, you don't have to pass field names. It will automatically check the first row for it. And now you see it converted into a dictionary. So dict reader means it will read it as a dictionary. Each of the row as a dictionary. So John is the name, marks 11. Jenny is the name, marks 12. Jacob is the name, marks 17, which is exactly the output down here. Now we can process it. Let's say we want to display the sum, right? So I can do it in one line, but let's do it properly. S equal to 0. S plus equal to row of marks, and we have to convert this into integer, because if you see the output, it is in string, right? And I'm guessing there might be some argument that you can pass to let it know the types, but I have not used it before. So now let's print the sum is S. Let's run the program. Sum is 40. Let's calculate it. 11 plus 12 plus 17. So this is 10 plus 30, 40. Correct. Right? If I go and add a new line, John, Jenny, Jacob. What is another J name? Julie. Now this should come 60. Nice. Very basic stuff, but think of how you can mix and match this all concepts that we have learned in 2 live streams to create interesting programs. I really like this sort of programs, like handling files, reading them, modifying, writing back, right? Doing stuff in bulk with small piece of code. That's nice. But yeah. Similarly, there is a dict writer and writer for writing CSV files. Make sure you open the file in write mode, and that's it. Cool. This was working with CSV files. Any doubts in this? Anything you want me to cover? Am I not doing oh, am I going very fast or very slow? What is happening? I'm not getting response today. Or whoever watches after this live stream, right? What's How do I go to my chat? Yeah. Yeah, 9 people are watching, but no response. Come on. Design and template. In what context are you speaking, MK? So the design and template can mean anything depending on the context, right? Design can mean website design, template can mean Jinja template, but you might be speaking in some context. Cool, let me know. What's the design and template? I don't know, I haven't heard of. So are you talking about the template that you download while data import? Is it that template? Not sure. Cool. Let's proceed. We have a lot to cover. Just one more kind of file that I think useful for Frappe folks is config.json, handling JSON files in Python. JSON files look like JavaScript object notation. So JSON stands for, and they look like JavaScript objects. So let's say my secret, let's say license key. Okay. And I want to read this file. So again, this is a text file but has a certain format, right? So I can't directly read and parse it myself. So Python has JSON module. So you can open a file, config.json, right? Read mode is fine. And I want to say json.load, give it the file, and it will give you, it will go and parse it to Python data structures. So I can directly print this, right? This made this a dictionary. See? So you can check type dict, right? So we couldn't have done this manually very, this is not trivial, going and converting stuff properly. Days remaining. Here it can parse the types, etc. Okay, we don't want the type. License key, days remaining 11. See, it's an integer. Nicely handled. There is also YAML out of the box. YAML is also a configuration file. TOML is there, which is a fairly new configuration file format. Nice. This was handling files. You can even handle image files. So there is a package called PIL. Pillow is there. Uh, that will help you process, like you can read images, make them grayscale, do all sorts of filtering stuff dynamically, decrease its size, get its width and height, all sorts of stuff. So yeah, this was file handling. Let's proceed. So the next topic is decorators, because I think that is helpful in understanding how this uh, at frappe.whitelist thing works. Do I cover that or I go in depth of something else? Just let me know in the comments. So by the way, like very nice official YAML, Python, and you can just look for the documentation. See YAML, and then JSON, Python 3. Yeah, JSON encoder and decoder. Really nice docs. You can just read along. It has examples. Design file is the name of the variable. Like, see, so MK posted some piece of code here. I will just copy it here. Can I? Let me copy, please. So I was going to go into the width part of it. Let me just go in there. Now it makes sense. These two are variables name. This can be anything. So I will tell you what width is. So you will explain this code better. So what were we doing till now, right? We were saying text sort ideas dot txt, and we had to close this manually. But there is a way using context managers, like using the with statement, you can say Like instead of storing it in a variable here or closing it here, you can say with open as f print f dot read whatever. So what will happen is when you use the with statement, right? It will open this and store this inside the f variable, right? As f, and you can do all sorts of stuff whatever you want with f here. As soon as the body of this function is over, right? Body of this with clause is over, it will automatically close it. So now if you try to do f dot closed, right? You will see it is closed, true. If you print the same thing here, f dot closed, you will see it is false, right? Is the property, it tells you whether file is open or closed. See, so automatically once your execution comes out of this block, it will automatically close this file. So you don't have to remember to close it manually. And now I bring back your code, which you shared, right? Which was this. This is just the name of the file which is being opened. Templates is also the name of the file which is being opened here. That's it. So there is no concept of, like, this is not a CSV related term, right? This is generally like whatever the uh, developer thought that was a good name for this file, he gave it. So you're opening the file, delimiter, you understood, right? By default also it is comma. If you don't pass this, it is still comma. Cool. Let's do decorators. Interesting stuff. I have a good example here. So we will make our own whitelist method. We'll make our own whitelist decorator. A simple one indeed, but we will work just like that. Just do it. I want emojis. Parapa, parapa. Just give me a second. Hmm, cool. So where were we? Yeah, decorators. So before we can go to the concept of decorator, we have to understand the magic going on here. So I have this add function, right? Simple add function. Then I have a subtract function. Very simple subtract function. Cool. So I have two functions. And you can store them in variables. Just like anything else. So you can store function in variables and then you can call them, right? 10, 11. Let's print this, right? So it will call the add function with 10 and 11, which is 21, correct, right? So functions are first class in Python. So they are treated like any other object, right? So what you can do is you can pass function around other functions. So, so I will write my function. My, let's write operator, right? Which takes two things and a function and returns. Don't like this is crucial. Just bear with me. I'll just call like the value equal to operator 10, 12, add. What did I do? I created a new function called operator which takes in three arguments a, b, c, and func, and I'm passing add, which is a function, to this operator function. So I'm passing a function as an argument to another function. Just think for a bit. This is not very complex. You're passing it, and that function is calling the function that you passed with the arguments that you gave. So if I print the value here, what will happen? Operator function will be called. It will get a as 10, b as 12, and function as this add function, this one. And it is calling that function for us. It is calling the add function with 10 and 12, which means 22, which is correct, right? So if you understand this, you will clearly understand what decorators do. That's it. Parappa, parappa. This makes sense. So if I just pass in the sub instead of add, right, it will subtract the 2. 10 minus 12 is minus 2, right? You get this, that you can pass functions to other functions and they can call them inside them. That is fine. So what you can do is you can modify functions as well, like return a new one. So suppose I have add and subtract. I write a describe function, right, which takes in a, which doesn't take in anything, which takes just a function, right? Describe, or let's say announce. Let me just write this function and I'll explain what I am going to run, right? Def modified function. Okay, just stay with me. No, this is not overriding the other. Watch again and we'll get it. So I wrote a function, right? That takes in another function called, like we named it func, right? And what I'm doing is I'm creating another function inside the function. You can create it like global local scope, right? And then I'm printing I'm going to run, and then I'm calling the original function that the user gave me, right? And that function I am returning as the value of this announce. So now I can say updated add equal to announce add. What is this? Takes a and b, of course. Pass a and b here. Okay. See what's happening? I said I called announce on add, right? So func became add, and I'm returning this modified func, which prints something and then calls whatever you gave. So in this case, it will call add with a and b, but before that, it will print stuff. So now you have an updated add. So whenever you call the updated add with something, it won't just call add normally. It will first announce that I'm going to run, and then you can print and return none because we are not returning this. Yeah, see 3. Not very complicated. Again, I'll explain what it is doing. Maybe whiteboard is required. Let's copy this here. Okay, cool. Now I want the green. Let's move it here. So I have created a function, right, that takes in another function. So when you called announce with add, right? This add is func, this variable, right? And inside this function, I'm creating a new function called modified function. You call it anything, which takes in A and B, right? It prints some things, right? It prints that I'm going to call the function that you gave me and then calls it for you, right? A and B, right? So when you called announce, it went and created this function called modified function, and then it is returning that function. See this line? So this returned this function to you to catch, and we stored it in updated add. Updated add is a function that was created inside this announce function, right? So look at it like this: add, add, right? We passed add. So this return, this func is actually the add function that we passed. So in a sense, you are modifying add, right? You are modifying the add function by extending. See, you can even do whatever you want, right? Before returning, you can process the output. I hope this, like, it takes some time to clarify. Even I was not able to get it the first time because it's like a lot of function, but nothing fancy here. You have a function that takes in a function, gives in you new function. Okay, let's do it in a diagrammatic way. You have a function calls announce, right? This is a function announce. This is a function. Cool. You give it as input a function func. It returns a new function, right? Don't understand last student. You will. I'm again explaining. So we created an announce function that takes in a function, which is this func, right? And then it returns a new function, which is the modified function. You can call it new function or the modified function, which you can store wherever you want. So we stored it in updated add. This is the concept, right? There is a function that takes in one function and returns a new function. This is the concept of decorator as well. I'll come to it. But does this diagram make sense? That the announce is a function which takes in func and returns a new function. And what that new function is? These three lines. See, this new function prints that I'm going to run and calls the older function. So this new function, right? This new function takes in the same AB. It prints stuff. This is where the output I am going to run is coming from, right? I am going to run and then calls the old function that you gave it, this old one. So the new function does something extra and then calls the new one. Make sense? So you are modifying the function's behavior in some way. If you called it directly, if you don't do this and you call add directly, right? Add 1, 2, what you will get? Will you get the print statement? No, you just directly got 3. But in this case, what we did, we created a new function by calling announce. So announce re returned a new function. It is not returning the same function after editing it. It returns a new function that inside it calls the old function. But before that, it announces, right? Which was the feature we wanted. So it announces. Now is it clear? Like maybe rewatch and try some stuff. Like I know this is not very straightforward to understand. That's why I kept it for the end. Once more, what are we doing? We wrote a function that takes in a function and returns a new function. That's in simple terms. And that new function can do whatever want. It can be a very bad function that doesn't call your old function. So now you will get a different output. You will get -1. So updated at is a function. See, it is not calling it. It is returning the name of the function. It is not calling the function. It is just returning the address of the function to you. So if you try to print this, right? Let's try to print updated at. See, it's a function which is this modified function at this memory location. So this thing, right? Makes sense. And then we stored it in updated, and then after we are calling it, it returned the function. Go ahead and call it. It gave you a new it gave you a new function with new behavior, and it's our task to call it. Cool. So this part is so common that there is a separate feature in Python to just do this part of calling a function and getting an updated version of it. So suppose I did this, right? What did I do? Now I basically overrode the original add. I stored the new function in add itself. See? So now what did I do? I modified it. This is where decorators come in. Now I'll move this announce to the top, right? And I will say at announce, same output, same output. So this is, you can call it syntactic sugar or whatever you want, but behind the scenes, what it is doing, it is going and doing this. These are decorators. That's it. If you understood the first part, that it announce takes in a function and returns a modified, like returns a new function, right? Which in turn calls the old one, right? This is what decorator does. Now writing a whitelist method from scratch, whitelist function from scratch will give you more idea. Let's do that. So what Frappe does is like it keeps track of. So suppose I have slash API slash method, some function name, right? You can only call it from the front end if it is whitelisted. That's the concept in Frappe. You remember that, right? So somehow Frappe has to keep track which function are whitelisted, which are not. For that, you as a developer say get stock and you add a decorator frappe.whitelist, right? You add a decorator and get stock is magically somehow tracked that okay, get stock it whitelisted. So we'll implement that. So Frappe stores it in a list or set. I don't know, but I will store it in a list. So let's call it whitelisted functions. So there is a set data structure. You can use a list as well. So set is a data structure which cannot have duplicates. So I can, so since we are learning, let's learn sets first. Python 3. My set equal to, so 1, 2, 3. Sets use curly brackets. And the difference between this and dictionaries have key value pairs, this just have values. And you defined a set and you can add new values to it. If you add one, right? If you append a one to a list, it will add two ones. But in this case, if it's already there, right, it won't add it again. So sets have a constraint that all the values inside it must be unique, right? That's a set data. And the check operation is very fast. You can check 2 in my set compared to a list. You can read more about some data structure algorithm related stuff, but sets are faster membership checks. Okay, cool. Let's exit here. So now you know why I'm using set instead of a list, because if you whitelist, like if the same code runs and the function is already whitelisted, why again whitelist? Why again add it to the set, right? That's the reason. So it's an empty set. This is the way to create an empty set. Cool. Use list if you want. That's also work. Cool. I'm use set. What should we do now? So suppose we have get stock, right? Which returns some stock. I have other method get balance, which return other balance, get empty balance, return balance zeroed, right? So I want this to be whitelisted, this to be whitelisted, this don't want to be whitelisted. So manually, how would you do it? Like you will go and say whitelisted methods. Manually, I'm saying dot add get stock, right? And then you will say whitelisted methods dot add get balance. And then if you print the whitelisted methods, see, there are two functions inside this set. One is the get stock, other is get balance, right? We added them manually. But think of from a perspective of a Frappe developer or an app developer, right? Does framework know how many whitelisted methods you have? Or as a developer, if every time you had to uh, do whitelisted, you need to access to a global, you need access to a global variable and you have to add it manually. Isn't this much more easy, right? Behind the scene, it will do the same thing. It will add your function to this set. That's what we have to implement. But we have to implement is as a decorator. So I don't have to do this manually and maintain this set myself. As soon as you call the decorator, Frappe will do this behind the scenes and add your method to the whitelisted method, right? So let's do that. Nice. So I will remove this. We'll implement our own whitelist function, whitelist, right? Which takes in a function. Remember, adds this function to the whitelisted and returns this function as is. Now this is the simplest decorator you can write. You are not modifying or extending the or not returning a new function. You are returning the exact same function. But what did you do? You added it to this set. Now if I decorate whitelist, I run the program. Let's just print the whitelist. I'm already printing. See, get stock is inside this set. How did that happen? Due to this. So what is this equivalent to, this decorator thing? It is equivalent to get stock equal to whitelist get stock, right? That we saw in the previous part. And when you call whitelist with get stock, it goes here, it adds it to your set, the function, which in this case will be get stock, and returns the same function. So get stock remains get stock. But what special thing you did in between? You just added it to this set. This is how whitelist works. So you just use this decorator freely, and behind the scenes, Frappe will add it to its map wherever it is tracking. This is it. You want me to explain again? Let's do this again. So I wrote a function called whitelist, right? Which takes in a function, right? And outputs the same function again. So it's not modifying it. But behind the scenes, what it is doing, it is adding it to a set whitelisted methods. It added the function to here. So Whenever you call whitelist on a function, what will it do? What will it do? It will add it to whitelisted methods. That's it. And it will return the same function. So you can store it here. So what's a good way to write this? This is equivalent to at white list, right? So that's what we did. Decorators, these are called decorators. You are decorating the getStroke function with this thing, right? This is equivalent to this line. But you don't have to write this line, right? You can just decorate it with getList and behind the scene, Python will call getList with this function and store the value back to this function. That's it. We wrote our own whitelist. Now, hopefully you understand. Shazan asks, Frappe made by you? No. I do work with Frappe. I do contribute in the repos, etc. But not made by me. Started by Rushabh and then hundreds of engineers, contributors. You can check the Frappe repo. There are other products as well. ERP Next is there. New products that are coming in. But yeah. So we can do one advanced example of decorators. Cool. So I will leave it like a comment here. Okay. Is it clear now? MK Chaudhary, Rehan, are decorators clear now? Do some practice, it will be. But yeah, very nice thing. Functions, getting functions as input, returning functions as output, and doing anything they want in between, right? Ah. This is even simpler than what the first example we took, right? That returned a modified function. This is returning the same function, but doing some magic in between. Just adding it to some whitelisted thing. Cool. I think it's time as well. So let's wrap. I wanted to show you like installing and using external pip libraries, but maybe next time. Para pa para pa. Since we are doing decorators, let's do it completely. Try catch as well. Okay, fine. For next video, we have try catch. So Shazan says where to start Frappe from your. Okay, I'll now I have the answer. Few months back I didn't. So you go to the playlist. Start from here. Or better, go to frappe.school. I have assignments there as well. So start here. Yeah. This course has the complete first thing. Oh, someone gave 5 star. Nice. Today, 1 hour ago. Thanks, Jay Prakash. Yeah, start here. And then once you're done with this, right, this will has some hands-on assignments as well, some lectures in between, some resources. Then you can watch some playlists like this doctor appointments app with Frappe framework. So you can see framework in action. Then watch merchandise store. That's also a good one. So you can watch this one first and then merchandise store. This will give you a good idea of what can be done with the framework and etc. etc. Nice. I've been watching Office, so this nice comes from nice. No, what was his name? The Office. Nice. Who was it like they forgot? But yeah, he used to say nice, nice, nice. What was his name? Now I have to find out. Yeah, this guy, Kevin Malone. But yeah, it's nice series. But yeah, this was so there is one problem with like normally whitelisting. So you might have seen Frappe has also so so notice the difference between Frappe's whitelist and our whitelist. Frappe dot whitelist. This will give you even more headache. See, whitelist is a function. You're calling it directly. Here we just said this. We can't call this, right? But Frappe has done some magic behind the scene, which makes it callable so you can do this sort of stuff. Remember? So how is this magic possible? Right? So this is if you wrote this, even this inside a function, and then you return a function out of it. So I won't like, I think this is enough for today. Let's not go deeper. But yeah, the base you know, I am sure you will figure it out. So just look for one thing. Okay, I deleted the whole thing. Okay. So I'll just do one more example and then we'll wrap up. So I want to write, so suppose I have def add a b print a plus b, right? I want to write a decorator, right? I want to write a decorator which says delay 1. So it should print, it should call this function, but after 1 second. So how do you stop time in Python? So import time, and if you do time dot sleep, right? And you pass in 1, let's comment this out. So you can make Python sleep or wait for 1 second. So let's say 10. So it will print this 1 second after. So you can do 3 seconds. 1, 2, 3. See. So this time dot sleep is very useful. So we have to implement this, but using a decorator. So it takes in any function, it calls it after how many number seconds you are giving, right? And we don't know, any function can come, right? Suppose we have the negate function, which takes in something and prints the negative of it, right? And we want to use delay there as well. Make sense? So let's start writing this delay decorator, right? It takes in seconds. And next time I will also remember to cover type annotations. Okay, right? So it will call your, see where am I getting the function, right? So this is not the actual decorator. We want to call this will return the decorator. Def delay. Let me just explain. Bear with me. Decorator. This is how the actual closer to how the actual whitelist works. Now this will take your function. This will time dot sleep for the seconds you have passed. This will return your function or call it for you. Yeah. Return your function. Okay, not no. I'm sleeping it at the wrong place, I guess. First, delayed function. Let me just complete it first. Star args, star quarks. We learned about it, right? This is why we learned about it, because we don't know what function like the user will give us for the modification, right? So we'll catch everything and pass it to our beloved function that they are giving us to modify. And then I will return this function. Sorry, call this function. I will, from this, we don't have to return. We have to return the delayed decorator. And then, oh, this is complicated. So don't worry if you don't get it. Delayed function. I will try to explain. I'm not sure if I'll be able to, but function. It will be a good challenge. Yep. Seconds. So we have to delay. Wait. Yeah. Let me just complete it. Time dot sleep. Seconds. Okay. Now this will work. Let's see if it works. Let's call add 1 2. Let's add a delay of 2 seconds to this function and 3 seconds to this function. Okay, delayed. Nice. So this decorator works. So here is what we did. We wrote a function that returns a decorator instead of directly a function that is a decorator, right? Because we wanted to ask for seconds. So what this will do is this will be replaced with the decorator that is returned and the seconds that we passed here. So this is the decorator we were playing around with till now. Now we wrote a function that returns a decorator instead. So think about it. A function that returns a function that takes in a function which modifies the function and returns a function. Just think about it. Just look at this example for few days. You will get it. But yeah, so this is a delay function which returns a decorator. So this is what's actually happening behind the scene. So if you don't use the decorator thing, you are basically saying delay, right? 2 seconds. This returns the decorator function. You are calling it on add. This returns a delayed add, right? And then we are calling in the delayed add, delayed. With whatever we want, right? Make sense? So instead of delay being the decorator, delay returns a decorator when you call it with the number of seconds. That decorator is for 2 seconds. And then if you pass in 3, it will return a decorator that modifies the function for delaying 3 seconds. Think about it. Yeah, this is it. So normal decorator combined with a function. So this is how frappe dot whitelist as well works. So somewhere in the code base, or why not open source, right? This wrap thing, whenever you update it starts behaving very differently. Frappe bench 0 apps frappe code dot, it will look, oh no, what's happening? I'm unable to click with the mouse. Whitelist, let's search for def whitelist. See, here it is. It takes in allow guest, access is safe methods, inner function, right, which is the actual decorator, and then it does some magic stuff, right, and then adds it to see the set, it is also a set, which is what we implemented, right, whitelisted dot add function, and then it has another set for guest method separately, and then it returns that function, and then it returns the inner function as the decorator. That's it for decorators. It's advanced concept, like I won't categorize it in intermediate as well, intermediate to advanced, but yeah, there you go. I hope you enjoyed and learned something new. If you did, drop a comment. Usually a good indicator of how the content is doing, so I can plan accordingly. So drop comments with suggestions, feedback, and learnings. Nice. If you learn something new, my goal is completed. Before you go, I'll tell you one thing about decorators. That is, when we added this whitelist, right? Or like the even before that, that changes the location of the function. So if you say get stock and do white, do some my decorator, and that decorator returns a new function, the address will change. So to prevent that, there is func tools in Python. So read about it if you ever get stuck, which provides functools.wraps, which you can wrap the function. It will keep the, it will, what do you say? Keep the old address of the function. That's it. So functools, I will share it in the chat if anybody wants to dig deeper. Yeah, that's it for today. By the way, before I leave, the Vue.js batch is happening. I have formally announced, haven't formally announced it. Rapper.school/LMS batches Vue.js training. So out of 25, only 17 seats are left now. So it's happening from 10 June to 14 June. That is not long ago. Bench migrate for only one app. No, bench migrate is for site. So it is per site. Because the database is for the site, right? Not per app. So if you want to prevent some migration, like stash the JSON of the apps, right? What actually is migration? It will check your JSON of all the apps and reflect it in the database. If you don't want 4 of the apps to get their JSON changes to be migrated, just remove the changes, stash it using Git, run migrate, bring them back. Hope that answers your question. But yeah, I'm working on a course, should be out by before the end of this month. I'm working on assignments now. I have completed the, what do you say? I have edited each of the separate videos out of our last live stream. So maybe I'll do the same thing with this series of Python live streams. So entity relationship, joining tables, yeah, all cutted out and edited for to be made into a course. Nice. Cool. Goodbye, everyone. Have a nice day. I will probably see you on Sunday or not if I'm tired because I have to leave for Mumbai on Monday. So that week I won't be here. So no live streams. Bye bye.